This is lecture video 53, and we will cover improper integrals of type 2 in this lecture. First, we need to recall that the improper integrals of type 1 occurs when the interval of integration is infinite. So like this, from 0 to infinite, if you are integrating a continuous function, you cannot treat it as a nice definite integral because the interval of integration is infinite. That's why you need to treat it as an improper integral of type 1. Now, we will talk about improper integrals of type 2, where your function has a vertical asymptote over at some point, which is inside your interval of integration. So in other words, f of x is discontinuous at some point inside this interval AB, then you call it as an improper integral of type 2. So look at this example. At the point 1, the function inside is not continuous, right? So this function, f of x equals 1 over 1 minus x, is not continuous at x equals 1. And this point is in fact the upper bound of your interval. Such integrals is called as the improper integral of type 2 because of this discontinuity point. Improper integral of type 2. And how do we fix it? By using a similar idea to fix the improper integrals of type 1, we can handle this improper integral. So the problem is about this point, right? Okay, this time interval is finite, but the problem is that this function has a discontinuity point here. That's why you will put a variable like b to the problem, to the place where we have a problem, and then by sending b to 1, okay, so you have this interval, b need to be chosen inside your interval, so b goes to 1 from which direction? From left. That's why one-sided, from left, we will put this one-sided limit. So that's how you handle improper integrals of type 2. You send b to 1 from the lower direction like that. Okay, so let's try to understand all the other cases. So starting from this example, I think you got the idea how we should fix the improper integrals of type 2. Type 2 means the cases where the interval is finite, but the problem is about the function having some discontinuity points over this interval of integration. Okay, so look at this table. And in the first case, you see that the function has discontinuity point at x equals a at this point. That's why we put another variable named c there, and then you need to send this variable c to the lower bound a from the upper direction, so plus direction, so right-hand side limit. And similarly here, we have discontinuity at the upper bound. That's why I put c there, and then I need to send c to b from the lower direction. That's why this kind of one-sided limit. And in the third case, our function f of x has a discontinuity point at the middle point c. So you need to divide the integral into two parts now. And these two terms are the terms that we handle in the first and the second item. So the discontinuity point is at the upper bound. So this is the second case, you know how to handle it. The discontinuity point is at the lower bound. This is the first case, you know how to handle it. So let's apply these kind of fixings for improper integrals of type 2 to these examples. Okay. This is an example of improper integral of type 2, right? So this is the one that I mentioned here. Let's complete the solution for it. Okay, so this function here has a discontinuity point at the upper bound x equals 1. So let's write this down again. Is this continues at x equals 1, which is the upper bound of the interval of integration. That's why you need to treat it as an improper integral of type 2. Okay, how to fix it? Of course, you need to put some variable for the point 1 there. So let's put b. Whatever variable you choose, you can choose any variable you like, and then you need to send b to the point 1 from the inside of your interval. So we are approaching 1 from left. That's why I need to put this one-sided limit here. So the rest is just computing this usual integral. So this was 0. Okay, so what we have? We have limit b goes to 1 from left. And now this can be easily integrated, right? So let me write down below. Okay, what is the result of this integral? dx over 1 minus x. If you call this denominator as u, then du is minus dx. That's why this integral is written as, this is minus du, now minus du over u, so minus ln absolute sine of u, where u is this one. So let me continue from here. B goes to 1 from left, and the result of the integral is like that, minus ln 1 minus x, and then I will insert upper lower boundary 0 to b. After doing these insertions, I will take the limit, okay? Limit b goes to 1 from left, so insert the boundaries, minus ln 1 minus b minus minus plus ln 1. This is what we have inside the limit. So this is 0. And we need to remember the graph of the ln function, I guess, to compute the result of this limit. This is ln x, and as x goes to 1 from left. What, by the way, okay, ln 1 is 0. If b goes to 1 from left, what happens to here? This part. So this part goes to 0 from right. So if x goes to 0 from right, the results are getting towards the minus infinity. There is another minus here. So this goes to minus infinity as b goes to 1. Minus minus plus. So the result is plus infinite. When the result is not finite, it is an infinite value, you call that your improper integral diverges. Okay, like this. Okay, let's move on. We covered here an example of improper integral of type 2 because the integrand function has this continuity point at the upper bound. Okay, let's look at this example now. This time, this continuity point is a middle point, as you noticed. Okay, so what is f of x here? The function is 1 over x minus 1, 2 over 3, and it is discontinuous at which point? At x equals 1 point, which is a middle point, which is inside the interval of integration. So if your function is continuous at a middle point, how do you handle the improper integral? You divide your integral into 2 parts at this discontinuity point, right? Okay, so we understand that this is an improper integral of type 2. So let's try to fix the problem. So 0 to 3 dx over x minus 1. By the way, you call your integral as improper integral at the point 1. Depending on the discontinuity point, you can call it as improper at x equals 1. Sometimes they call it like this. And now what I will do to fix the problem is to divide this integral into 2 parts from the discontinuity point like this. X minus 1 to the power 2 over 3 plus from 1 to 3, of course, 3 dx over x minus 1, 2 over 3. Okay, now I have two improper integrals of type 2, right? So the problem is here now for the first integral. The problem is here at the lower bound. So I know how to fix these problems. For the first integral, I name it as b. And then I will send b to the point 1 from the lower direction, like this. So this one-sided limit will be applied. Sorry, from the lower direction means from left, like this. And for the second integral, I will do a similar operation. So let's name this problem as the variable c, dx x minus 1 to the power 2 over 3. And then I need to send c to 1 from the upper direction. So this type of one-sided limit I should use. Okay, if I compute the integrals first and the limits, I will obtain the result. So let's try to handle this integral. Maybe I can put a recall at this point here. Recall, how do you integrate this? dx over x minus 1, 2 over 3. So you can call this part as u, then this is exactly du. So the integral is in fact u to the power minus 2 over 3 du. That's why you add 1 to the power and divide by the same power where u is x minus 1, right? 1 over 3, 1 over 3. Okay, like that. So I need to write limits. b goes to 1 from left. The result of the integral is computed here. It is x minus 1 to the power 1, 3. So there is another constant 3 in front, as you can see. All I need to do is to insert upper lower boundaries. And similarly for the second term. This time, limit c goes to 1 from right. Result is 3 times x minus 1 to the power 1, 3. And then I need to insert c to 3. Then I need to complete this limit. So what we have inside the limits, let me write that down. Limit b goes to 1 from left. If you insert b first, you obtain 3 times b minus 1, 1/3. If you insert 0, what you obtain? Okay, if you insert 0, I think it is minus 1, so minus 1 plus 1. I just separated this 3 constant in front. Okay. Like this. This is for the first limit, and what happens in the second limit? You first insert 3, okay? So 3 times 2 over 1/3. And then minus 3 times c minus 1, 1/3, like this. Okay, so now let's look at the limiting case. b goes to 1, then this part goes to 0, right? That's why the result of the first limit is 3. And when c goes to 1, this part goes to 0. And the result of the second limit is this number here, right? Plus 3 times 1/3. And as you can see, the result of the integral is a finite number, which means I can call the improper integral as convergent. So since it is a finite value, the result improper integral that we computed, integral is convergent. If it would be infinite, we would call improper integral as divergent, okay? So that's it for this lecture video. We understand in this example how to handle improper integrals of type 2, where the function has a middle discontinuity point. Then all you need to do is to divide your integral into 2 parts like this at the discontinuity point. Then you will name B, and you will send B to 1 from left. And here, the discontinuity is at the lower bound if you put a variable there, C, and then you need to send C to 1 from the upper direction, this one-sided limit, okay? I stop here.